Let's take a look now at the next example involving arithmetic sequences. So if we look at this question over here, what are we given? We are told that we're given a sequence and they want to know which term is equal to minus 13.5. So the word which term, you need to start learning terminology. When they say which term, they're looking for n. You don't know the value of n here, but what do you know? Well, what we do know is that we've got term 1, term 2, term 3, and this one over here is a certain term in the sequence, term n, which we don't know, is minus 13.5. So what we do know that a is equal to a quarter. We know that we've got the first, second, and third terms, so the starting point is let's go and see if this is linear. Let's go and subtract. Let's say t2 minus t1. Term 2 is minus 1, minus a quarter is therefore minus 1 1/4. Another way of writing minus 1 1/4 is minus 5 over 4, because 4 and 1 is 4 plus 1 is 5, so it's minus 5 over 4. But what is term 3 minus term 2? Does that also give you the same answer? Term 3 is equal to minus 2 1/4. We must subtract from that term 1, which is a quarter. So we've got minus 2 1/4 minus a quarter. In fact, it's plus a quarter. Sorry, that was a minus 1. Sorry, this is actually a minus 1. We're doing t3 minus t2. Minus 2 1/4 minus t2 is minus 1. So it's minus 2 1/4 plus 1, which gives you minus 1 1/4, which gets you back to the minus 5 over 4. So what we found here is that term 2 minus term 1 is actually equal to term 3 minus term 2. So what do we know? We know that term n, the unknown, is equal to minus 13.5. Another way of writing that is 2 13s are 26 and 1 is 27. Minus 27 over 2 is equal to term n, but we're looking for n. So now we can say, but term n has got a formula. It's a plus d bracket n minus 1 equals minus 27 over 2. But we can start substituting our numbers. The value of a here is a quarter, plus your d value is minus 5 over 4, and then your n you don't know is n minus 1. And that's all equal to minus 27 over 2. I don't like this quarter. Let's take it over. So we can say minus 5 over 4 bracket n minus 1 equals minus 27 over 2, and this a quarter on the left, let's say is minus a quarter on the right. Let's go and simplify what we get here. We're going to get minus 5 over 4 bracket n minus 1, let's leave that for now, equals the LCD of 2 and 4 is 4. 2 goes twice. 2 times minus 27 is minus 54. Minus 4 goes once. So we've got minus 5 over 4 bracket n minus 1 equals minus 55 over 4. Now what I've got is a common 4, so I can actually multiply everything by 4, and by doing that I will actually drop the 4s. So you'll then land up with minus 5 multiplied by n minus 1 equals minus 55. We've multiplied by the 4s, essentially getting rid of the 4s. So minus 5 times n is minus 5n, minus 5 times minus 1 is plus 5, equals minus 55. Let's take that 5 over. So what are we going to get? Minus 5n equals, take it over, minus 55 minus 5. So minus 5n becomes minus 60. So that means 5n is 60. Divide by 5 on both sides, n equals 12. So what we've just worked out is that the 12th term, t12, is the term that equals minus 13.5. So how did we do this question? It's no different to any other linear or arithmetic sequence we've done before. It was just a bit tricky because you've got fractions. So when you've got fractions, make the fraction one fraction. So the 13.5 became 27 over 2. We eventually got an equation where the denominator was 4. Multiply out by that denominator and then simply solve your equation for n. In this case, n became 12, so the 12th term was equal to minus 13.5. And remember to start every question, first work out, are you dealing with an arithmetic or geometric sequence, or is it quadratic? What is the pattern that you're seeing? In this case, the pattern was that there was a difference of minus 5 over 4 from one consecutive term to the next. How did we work out that d? We said t2 minus t1 was equal to t3 minus t2.